video, we're going to explore using the Descriptive Statistics Toolbox. Now, to do this, we're going to need to get some data. And I'm going to bring in some data using the Import from File toolbox. If I drag it out onto the whiteboard, if I double click on it, I'm going to be able to run it. And I'm just going to use the simplest case of loading a file here. Now, I have a USGS file. It's come from WaterWeb. It's just a text file that contains some daily discharge data. I'm going to bring this data in. I'm going to treat it as a time series. Now, this is actually an interesting import from file example because we've got a skipped column character, or a skipped line character for the header information. If I specify the hash mark as my skipped line character, it's going to jump over all those columns for me. Now, the other thing I want to do is go to tab delimited, not comma delimited, because it's a tab delimited file. And you can see now we parse into columns correctly. We also need to specify the third row as our import row because we still have two lines of headers that define what these columns are. So if we go to the next step, we can start telling AQUARIUS what each of these columns are. That column we're not going to need to import. This is the site number, so we're not going to need to import this one. This column here actually represents the date and time, so if I click this one as date and time, this one looks as though it goes 4-digit year, YYYY, dash, then it's the month, MM, then it's the day, DD. And if we look here at this column, this is actually our daily discharge. So I'm going to say this is the flow for site 055145500, and the units for that are actually going to be in CFS. This last column is a flag column. We're not going to need this column in this case, so I'm going to click to skip that column. And then I'm going to go forward and click to next. This is where we could save this as a configuration. Since this is a one-time import, I'm not going to actually go ahead and do that, so I'm going to click finish, and it's going to parse through that file for me. Once it's finished, it'll give me that time series right here, and if I click done, it's going to show up on the right-hand side of my toolbox. Now, if I right-click and quick view that data, we're just going to have a quick view of what the data is here. So it looks as though there's a reasonably length gap in the time series from around after 1973 for a few years. So what we want to do actually is now pass this to the Descriptive Statistics Toolbox, and that's in the Math and Statistics portion of AQUARIUS. If I grab a Descriptive Stats toolbox and drag it out onto the whiteboard, I'm going to be able to wire my data across from the import from file to the Descriptive Statistics. If I double-click on Descriptive Stats, it's going to give me the interface for going through and generating statistical information on my data set. So to start with, we need to think about what kind of time range we want to bring our statistical information out at. Do we want to calculate statistics on the full length of our time series, or annual statistics, seasonal statistics, monthly values, weekly values? Now, daily values wouldn't be appropriate in this case because we have a daily time series to begin with, but if we were dealing with a 15-minute time series or a 5-minute or an hourly time series, we may legitimately want to compute daily values out of our particular time series. In this case, let's calculate some weekly statistics. And things like the weekly minimum or the weekly number of data points, maybe the sum of the values over the course of the week, that could be useful for calculating total flow through a point. If we then went and multiplied it by the number of seconds there are in a week, we could do that very easily. Things like the median value, the range, the standard deviation, kurtosis, skewness, and interquartile distance. And also if we want to know when we're above a threshold, say maybe we wanted to know the number of days we spent above 2,000 CFS flowing through. And maybe we also wanted to know on a weekly basis how many days were we below 20 CFS. And all we have to do is click the compute button, and it'll actually generate a table of these values for you. I'm just going to pin those two tabs across onto the side so we can see this table in all its length and breadth. And you can see here on a weekly basis, starting at the beginning of the data set and progressing forward, how many data points there were every week, what the minimum value was, what the maximum value was, what the sum of all those values were, the mean value, days above that threshold, days below the threshold, and we can see all of those values for us. We've also computed some output time series. So if I bring out my descriptive stats and pin these out again, we can see that we've actually decided to compute output time series of weekly minimum values. So of weekly minimum, weekly maximum, and weekly mean. And if I close this toolbox down, we'll see on the output of our toolbox we actually have 3 time series. One here, and one here. This is the day, or this is the weekly minimum, this is the weekly maximum, and this is the weekly mean. We can right-click, of course, and quick view these, because these are, of course, absolutely just time series values that we can work on. And you can see here quite a large value as we went through. There's probably a bit of missing data during that week, so we don't have true normalization. If we look at the time period running up to 1972, we can see our weekly average values, or in this case, this is weekly minimum values. So that concludes how we can actually use the Descriptive Statistics Toolbox to generate statistical information in a process way, or a way by going in and actually interacting with the toolbox. Another way we can do this is actually in a real-time process, and that's using another descriptive statistics toolbox. I can show you how you can do that. So the last time we double-clicked on the toolbox, and that's equivalent to running it as an application. If we go through and instead set up the process properties, we can go in and we need to tell AQUARIUS how to compute all of its results ahead of time. So in this case, we're going to calculate the same weekly statistics again, and we'll go into the stats that we want to compute. In this case, we can click on the statistics, and we're always going to generate an output port in this particular case. So I'm just going to turn a few of these on and a few of these off. We're going to go through and actually not compute a huge number of them. And for each one of these time series, we can have a manual description for its output or automatic. It's just the input signal name underscored by raw, because we're working on the raw data here, and then the suffix of what statistics we're actually generating. And the units, of course, would come from the input time series. If we want to change any of these, we can go to user defined. We can actually edit these, and I can say hello world, and we can just see where that comes out in the end. And the unit here, I could say, and this is going to be in CFS, of course. So if we go OK and we apply these settings and click OK to finish the toolbox, if we now click to run the process, it's actually going to go through and once again generate the 3 time series that we told it to run in the process properties. You can see here in the statistics we told it to compute 3 different statistics and output them. And one of them has a description of hello world, and you can see up there in the label it says hello world raw minimum. So that's how you can use the descriptive statistics toolbox in both a process method, or going in and running the application and sort of hand tuning those statistics, or doing it as part of a real-time process. And that concludes the functionality of the descriptive statistics toolbox.